Hello everyone, myself Shweta Shah, Assistant Professor at L.J. Institute of Engineering and Technology, Ahmedabad. We are here for the subject Computer Organization and Architecture. In this subject, we have started Unit 3, Assembly Language Programming. In this unit, we are going to see basic programmings. In last session, we have started with assembly language programming basic with basic machine language. In this session, we will further see assembly language programming. As we can see here, given one simple program of addition of two numbers stored at location 004 and 005, and we will store this addition at location 006. In this program, this table uses symbolic name for the instruction instead of the binary hexadecimal value, and the address part of the memory reference instruction as well as operands remains in the hexadecimal form. Okay, so it will be a bit easier for us instead of binary. Okay, and the inclusion of last column for comment is for a means of explaining your instruction. This is not a compulsory, it is optional. If you want to use, you can use. Let me see further this program how we can do another variation to this. LDA 004 at one location ADD 005, at two location STA 006, and at third location HLT. Okay, and that location onwards, there is your data, that is that address you have used in an instruction. In first instruction, your operand is loaded into accumulator. In second instruction, your operand of that address is going to be added into this accumulator. Then result is going to be stored at location 6 in ST instruction, and in hold instruction your program is going to be stopped. Okay, so here your program you can write like this. It is a bit easier than showing like this 2004, 1005, 3006. Instead of this, if you are given like LDA 004, then you can understand that you have to load number stored at location 004 to accumulator, add 005, that means you have to add 005 locations contained to the accumulator, and so on. Okay, so it is bit easy. Now you can see this is just this 4 lines represents just the addition of two numbers. The two numbers are stored at, first is stored at location 004 and second is stored at 005. It is just a program of addition of two numbers that you have stored at location 004 and 005, and you are going to store result at location 004. We can do one more variation to this. Here we have decided that we will store this instruction from location 000 onwards, but it is possible that your starting location may require for some another important task, right? So how you can change this location? You require to change this location. How you can change this location? Okay, so for that, and one another thing that here we have stored this number in terms of hexadecimal, but all the time we maybe don't know hexadecimal number, or we may not want to enter all the time hexadecimal number. Sometimes we require to process on decimal numbers. So how you can store that decimal numbers directly, and instead of that decimal, that actual binary pattern is going to be stored. How it is possible? Let me see. For that you have to use some pseudo instructions. Okay, for example, let me do just some variation, and here also we have used address in terms of actual address, in terms of actual location address. But what if we can give it as a label instead of like writing 004? We may not know at which address your operand is stored, but we may know the label, at which label your operand is stored. So we also can replace this address by some label. Okay, so we can do it this program like this. Here we have used org0 to represent. Here we have used org0 instruction.
to represent that your instructions are stored at location 000 onwards. If you want to change your starting location of storing instruction, then you can change by changing this 0 location. Okay, instead of 0 you can write 100, 101, 102, any location you want you can write over here. Okay, then LDAA, instead of writing LDA 004, that is your actual address, but if we do not know that actual address, but we know the label of that address, then we can write it as a address LDAA. A is our address of the label, A is our label of the address. Okay, that will be anywhere in your program. We doesn't know that's address. Okay, but we know its label. So we have used instruction over here LDAA instead of LDA004. Okay, similarly for ADD005, instead of that we have used ADDB. B is a label of your second operand. Okay, and then you are going to store this result at location C, and this is your label for a C. Okay, and then hold, as your program is ended, there is only 4 instructions are there. After that hold, you have to compulsory give the label. You have to compulsory store this label, so that whenever you require data, or whenever you are calling this address, so this address should be anywhere in your memory, but it should be there. Okay, so you have to store this A, B and C labels, and at that label your operand, whatever your operand is there. Okay, instead of that hexadecimal or binary number, I have used one another instruction, that is DEC N83. This instruction will store this decimal 83 number, but it tells compiler, it tells assembler that you have to store 83 decimal number. So it will directly translate this decimal number 83 into binary and then going to store. Okay, so this kind of change also possible. And this extra instructions ORG, DEC, END, that are known as a pseudo instruction. And is used to denote that your whole instructions, whole operands, all of these things are ended. Okay, HLT only denotes that your instructions are ended, but your data, your operand may be after that hold onwards. But and indicates that your all of the things, operands and data, all of these things are stored and ended over here. Okay, so you can store your programs like this. We can see these are your pseudo instructions. ORGN, here N indicates memory location for your instruction, and from where you want to start your start storing instructions. Okay, so by changing N, you can change starting location of your instruction. Okay, then N to denote end of symbolic program. Decimal N and hex N, that are used to store signed decimal number N to be converted into binary and then store at location, that location. And hex N is used to store hexadecimal number 2 at that location. Okay, so directly hexadecimal and decimal numbers are converted into binary and then going to be stored at location that. Okay, so that these are your pseudo instruction. So we have total 25 plus 4, 29 instructions to do programming. Okay, and next this type of programming is known as assembly language programming. Okay, so this here this language will have some rules. Okay, one more thing here, after colon we have after dash we have shown here something, some line that is known as a comment, which will indicates you what is this instruction has a meaning. It will show you the meaning of your instruction. Okay, this is not a compulsory, you can use if you want to. Okay, but labels are compulsory. Whatever labels you have used in an instruction, you must have used afterwards to store your operand. Okay, so as we are discussing that the all of the assembly language will have some rules. Okay, so let me see what is rules for our assembly language. Here in our assembly language, each line of assembly language program is arranged in 3 columns or 3 fields, that is known as a label field, instruction field and comment field. Okay, this is your label field, this is your label field, this is your instruction field, and this is your comment field. Okay, here your instruction can be any of, your instruction can be any memory reference instruction, non-memory reference instruction, that is your register reference or IO reference instruction, or pseudo instruction, any of this instruction. And first thing is your label. This label must be ended by comma to indicate that it is a label, otherwise it is considered as a some address, okay, or some label. Okay, so it is required that you use comma. Okay, you can use any symbol for this address, as we have used a over here. You can use any symbol for your address, but this symbol can be maximum of 3 letter, and first letter must be alphabet. After first letter you can use any number or any special character or anything, but first letter must be a alphabetic number. Okay, uh, how you can represent your MRI, non-MRI, and direct address, indirect address instruction? Let me see with one example. uh, CLA, that is your clear accumulator instruction, that is what your register reference instruction. Register reference instruction and IO reference instruction, also known as a non-memory reference instruction, or you can say non-MRI instruction. Okay, so for that non-MRI instruction you will just have a opcode, CLA, CMA, etc., CLE, that is all thing. Okay, and for MRI instruction, that can be of two types: MRI instruction with direct address and MRI instruction with indirect address. For MRI instruction with indirect address, you have to use instruction, then your address is label, okay, and then I keyword. Then you will use I letter, that will indicate that you have used indirect addressing. That means your address indicated by, and in PTR is your indirect addressing, and at that address you will find actual address and will go to that address. Okay, and here if you have used direct address, then that place will be blank. Okay, so add OPTR. So OPR is your actual address label. Okay, while PTR is your indirect address or indirect address label. Okay, so by that, by this way you can design assembly language programming. Okay, so we are ending today's session over here. In next session, next we will see assembly language in further details. Okay.